be live in seconds.
Okay.
Let's check if this is true.
At least it says to me that it's live.
Really?
Yes.
Okay. Okay. Yes, it's definitely live. So, hello everyone. Welcome to another interview of the series 2 weeks of databases. This is the second week. And we have an interview today with Marko Makela, which is InnoDB main architect at MariaDB. Hello, Marko.
Hello.
So just a quick reminder that after this interview, we will have a short interview with another person from MariaDB, who is Andrew Hutchins. It will be at 4. No matter which time exactly we end with Marko. So anyway, hi Marko. Do you want to maybe start with a brief introduction of you and maybe telling us about your amazing background?
Well, okay. I started work on the InnoDB storage engine in 2003. That was I was looking for a job after I finished my doctoral thesis. And I browsed the web for a couple of hours, maybe 3 hours, and I found this job advertisement of InnoBase, the company which was founded by Heikki Tuuri, who was back then a subcontractor of MySQL, and he was doing the InnoDB storage engine. So I was the first full-time employee of that company. And well, basically, I worked for InnoBase, and later Oracle acquired it, and I worked there until 2016, and then in December 2016 I switched to work on MariaDB. Things that I did include some alter table changes. I did the fast alter table in MySQL 5.1 InnoDB plugin, which became the InnoDB in MySQL 5.5. Also, I did some row format changes. I introduced a more compact row format in InnoDB. Also, I introduced a compressed row format. Those were back in the InnoDB plugin for 5.1. And then later on, I worked on some redo log format changes I have done on MariaDB, instant alter table, add column, drop column, and lots of interesting bug fixes. So long background on InnoDB. I know most of that code.
Okay, that's amazing. So you mentioned that you started to work at InnoDB in 2003. How old is InnoDB actually?
I think that Heikki started developing it in 1994 or something like that. And he worked on it for 3 years, if I remember correctly. And then he tried to sell it. So he went to see Microsoft and Oracle, and I don't know if there were other companies, but those at least he visited and tried to sell, and failed, of course. And then finally he met Monty, the founder of MySQL and MariaDB, and then they started the cooperation. InnoDB became part of the MySQL 3.23. Something release. I don't remember. That was a long time ago.
Oh yes, I remember it because.
So when I started, it was 4.0, and the 4.1 was under development. That was 2003.
Okay. Yeah, a lot of time passed. And so some of the people who is watching us probably is too young, or maybe they come from different technologies. So I want to say for them that InnoDB was a massive change for MySQL, because before InnoDB existed, MySQL didn't support transactions in any way.
Right, that is true. And even though in MariaDB we now have the ARIA storage engine, I think that most users who want crash safe operation, they use InnoDB. this ARIA engine was supposed to be the replacement of InnoDB after Oracle acquired our company, and MySQL company had to figure out something. So it was either the Falcon storage engine or ARIA. The Falcon is dead now, but ARIA lives on in MariaDB. So it's basically a crash-safe MyISAM. But I think most users are actually still using InnoDB if they want to have some crash safety and transactions.
Yeah, well, I can say that, of course, I don't know if my customers are a statistical sample, probably not, but I don't see ARIA used a lot, honestly. And I think that it's very, very far from being an InnoDB replacement.
Yes, sure. It doesn't support the rollback command. It only supports rollbacks on crash recovery. But internally, I think the optimizer is using temporary tables in the ARIA storage engine. So in that sense, it's being used if you have some order by or some complex joins or something that can't use an index.
Okay, yeah, great. Okay, so I have a curiosity, and it's possible that other people have the same curiosity. How is Marko Mäkelä's workday? I mean, you sit in front of your laptop, and then what do you do?
Well, mostly I'm developing working on some bug, trying to reproduce or developing some feature. So I'm happy that, or lucky that I can concentrate for several hours on the same thing. I also have a couple of colleagues in the InnoDB team at MariaDB. So I also do some mentoring, and we have a weekly call and so on. But most of the time it's rather lonely. Well, of course, some instant messenger, I answer questions from my colleagues and some community users who are on the Julep chat contributing to MariaDB. I interact with them, but mostly I'm concentrating and working on the code or the debugger. Okay.
So your job is, if you have to say a percentage, how much of your job is hands-on?
Well, let's say 90% at least.
Okay, a lot.
Yes, and I like it that way.
Okay, great. How big is InnoDB team in MariaDB?
Let's see, it's myself and then 2 other developers and then a QA person, and then from time to time some more developers. So I would say that it was 5 developers and QA at most when we developed this 10.5 release, which is soon going to be released as a GA.
Okay, great. So before going into the details of InnoDB and what you're working on, I wanted to ask you something, if it's something that you are willing to answer, of course. So you mentioned that at some point you moved from Oracle to MariaDB. Can I ask you what are the differences you see, and I mean the differences in the way of working, or what is expected from you, or these kind of things?
Well, one obvious difference is this cathedral or the bazaar thing, that Oracle back in the MySQL 5.5 days, it closed down the development. It used to have still an Oracle acquired Sun. At the very beginning, there used to be like real-time access to the code repository. I think it was on BitKeeper. No, it was on this Bazaar thing, this Launchpad. And then it was moved to GitHub at some point, but I think even before the move to GitHub, they stopped doing this real-time access. Only when they are releasing the binaries in a few days after that, they will release the commit history on GitHub. So that's okay. one big change. Another big change is that Also, the bug database is closed at Oracle, and generally employees are discouraged from discussing any like internal progress. Of course, it's a publicly traded company, so there are some laws in the US. There is this Sarbanes-Oxley Act that you must not promise things that are not completely sure to happen. So if some customer is going to buy your product based on something that you believe will happen, but it's not sure, then you are kind of what is the word? Like faking it or breaking the law if you make some promises. So we are not allowed to talk until it has been published, and because development is internal at Oracle, you are not allowed to say anything, basically. And there is this long delay that if there are some community contributors, they will not see the code. So if they are working on anything similar, you will basically do duplicate work. And well, what else? Then there was this organizational difference that at Oracle, there are no all-company meetings or anything like that. It's more like a military organization that you see your current, your own platoon or company, but not the division level or anything like that. You only see your own low level, and you are only allowed to talk to the other groups via managers. And then if some change would involve multiple teams or people from multiple teams, then it's not likely to happen. So at MariaDB, when I started, it felt like a small company again, that you get both the responsibility and the power to do big things.
Yeah. So we have some specific questions in the chat, but before asking you some of those questions, some of the persons who follow us probably come from other technologies. So it would be nice if you can give us a brief, high-level overview of what InnoDB is and how it works.
Okay, so the InnoDB is based on this book, Transactional Processing Concepts and Techniques by Gray and Reuter from the 1993, I think. So it was state of the art when Heikki Tuuri started developing it 1994. It uses B trees for storage, and it writes undo log ahead of the transactions or ahead of the changes. So if your transaction is changing something, it will first write the undo log, and then it will change the index trees. And when you commit, you basically mark the undo log header as committed, and that's it. And of course, you will use the redo log. You must, if you want the change to be durable, you must make sure that the redo log for this undo log change has been written, and that makes your transaction durable. And it has multi-versioning based on these undo log records. So if some other reader is trying to access a row and it notices that the row has been modified by an active transaction or by a later transaction, then it will fetch the undo log records from the undo log pages, and it will construct the correct version of the record. And then there are some additions like on top of this Gray and Reuter book, there is adaptive hash index, which aims to speed up accesses, basically key lookups. It's building a hash table, partial hash table to the index trees. And then there is a change buffer. If your secondary index page is not in the buffer pool, then the change can be written to a separate data structure which is persisted in the system table space. And later when this secondary index page is accessed, then the changes will be merged.
Okay. I will ask you some of the questions that people are asking in the chat. So dbdaemon asks if it is true that InnoDB is optimized for spinning disk and less suitable for SSD.
Well, yes, it's an old technology, and you can't really deny that. Even this change buffer, I would say that it's mostly written for the idea that random reads from the disk are slow, so you better write the changes somewhere else. So yes, I would say so. But in MariaDB 10.4, I made some trivial change that we are disabling this neighbor page flushing. When InnoDB is writing pages to the disk, it tries to also write adjacent changed pages to the disk, hoping to minimize the seeks. But this doesn't make any sense on SSD. So in MariaDB 10.4, I implemented an automatic detection of SSD, and we disable this neighbor flushing on SSD. But if you want a good SSD performance, then of course there are better storage engines such as the MyRox or RoxDB storage engine, which is available in MariaDB since version 10.2. It's optimized for, basically it's append-only files and very highly compressed, because basically it's sequentially written files, and those can be compressed very nicely. And that's a friend for SSD.
Yeah, great. So I would like to ask you, what is your favorite project you recently worked on?
Well, okay, for the 10.5 release, I worked on rewriting the InnoDB redo-log record format. That was a huge undertaking, several months of my time, and I now better understand why Heikki Tuuri was so conservative about big refactorings. Of course, he didn't have access to such useful tools like this RR project from Mozilla. With RR record, if you have some fairly easily repeatable bug, you can run it under RR record, and then you get the perfect trace for reproducing the problem. And that was very useful for debugging the last bugs in the crash recovery code after I did this new redo-log format.
Okay.
And generally challenging bugs, same thing. I'm very happy about this new tool that I found like a month ago.
Do you want to talk us about it?
Well, I only mentioned this rr-project.org. So, for example, last week I found a bug that had been introduced in MySQL 5.5 in the change buffering. It's in 5.5 we implemented this delete buffering and purge buffering, and there is a design constraint that a page must not become empty unless the whole table is empty, and that was being violated. And there is a MySQL bug, I think it was 61104, filed in 2012, where we had a hard assertion failing because of that. And back then I couldn't figure out what the problem was, and we were not able to repeat it Oracle. But now at MariaDB we repeated it with this RR record, and then with analyzing this RR replay, of course it took me several hours to analyze, but I was able to figure out that, okay, we had a bug in the hash function calculation, that we were supposed to calculate a hash value on the record, but we also included some garbage data after the record. And that garbage data was different for identical copies of the same record. And then we got failed to detect that we must not buffer the operation.
Okay, great. Going back a bit about the redo log. Do you want to maybe explain what are the benefits of the format changes you made?
Well, there were several changes. Initially, it was about reducing the redo log volume so that we write less data for the redo log. when I implemented this row format equals compact in MySQL 5.0.3, then I expanded, I did a simple change to the redo log. I added some index metadata to the redo log records. So that, for example, when you are deleting a record from a page in this compact format, we don't, the page itself doesn't encode the lengths of the fields of the index. So that's part of the index metadata. You must know the actual lengths of each field and also whether they allow null values or not. And this was being logged separately to the redo log. And of course, it was taking a lot of space there. And also in some other cases, the old redo log format was not optimal. It was writing more data than it should. And we have this contention on the redo log buffer mutex, and that makes actually makes a big difference. If you are writing like 20% more redo log bytes, then you might have a 50% less performance. And also crash recovery is much faster when you don't have to pass these index metadata records and allocate dummy index objects and so on. And also Maria Backup, the online backup solution, it's faster because it now has this physical redo log. We also did some other changes. When you are freeing a page, it doesn't make sense to, like if you're dropping an index, why should you write back the pages of the dropped index to the data file? Well, until MariaDB 10.5, we did that because we have this idea of write-ahead logging. So if you are making some change to the data file, you must write redo log for it. So what we did in MariaDB 10.5 was that I introduced a record for freeing a page. And also another record for, okay, we already had the other record for initializing a page. But this allows us to write fewer pages to the data files. We just write this record that we are going to free this page. And once that is durable written to the redo log, we can discard the page without writing it out from the buffer pool. And also recovery, we notice that, okay, this page has been initialized or this page has been freed, and then it will avoid reading the page from the data file at all. So if you got a corruption in the data file, recovery doesn't care about it because it will initialize the page based on the redo log. And also we can disable the double write buffer for these newly initialized pages because we know that the recovery can recover them based on the redo log.
Okay.
So it's a fairly small format changes, but big impact on usage, I hope.
Okay. I can see that the impact can be big. I would like to ask you about my favorite tasks because for those who don't know, well, MariaDB uses a public JIRA, so anyone can take a look at what they're working on and subscribe to bugs and tasks and see what happens around them. So again, I'm subscribed to some of these tasks and would like to ask you some hints about them and if you're working on them and when can we expect them to happen and so on. So one of them is I see that there is some kind of idea of moving the transaction logs into tables that should be that should be engine independent, right?
Well, yes, I filed that task. I think shortly after I joined MariaDB, I wanted to kind of make a brain dump of what I think we might do better in the future, while I still had some memory of what had been done at MySQL, and mainly that was related to this global data dictionary.
Okay.
So I was thinking that could we also do the undo log in a better way than and not only the data dictionary. Well, the short answer is that there hasn't been any progress on this. And at some point, I think I edited the task to say that maybe we should only have the common transaction metadata and keep the logs in each storage engine. Because I think what really matters is which transactions each storage engine knows about. And ideally, they should have a common identifier. So I wouldn't like to use this XA mechanism, which we currently use for this multi-storage engine transactions. Instead, I would like to have this sort of undo log header inside in the top level, and then each storage engine would then know whether they have a log for this particular transaction ID. But no, there hasn't been any talk on that, and I can't promise any progress on that. So what was the use case that you were thinking about?
Oh, I wanted to ask you what the use cases would be. But since you mentioned XA, very brief question. Do you agree with me that currently they have far too many bugs?
Yes, definitely. One bug that was finally fixed in MariaDB 10.5 is this MDEM 742. It was kind of fixed in MySQL 5.7. That when you have an XA prepare, it's supposed to mean that until the user says XA commit or XA rollback, the transaction will remain there in the system. But what happened in practice was that if the client was disconnected, then it would the server would roll back the XA transaction and completely break any hope of having working XA. So this was finally fixed in 10.5.
Okay.
And there was also some, I don't remember exactly because I wasn't completely involved with that. It was the replication team that worked on it. But there was also something related to the bin log handling and bin log crash recovery regarding related to that.
Okay.
And yes, we have a couple of other bugs. For example, if we got such an XA transaction recovered, then it will not hold MDL, the metadata logs for the tables that it modified. So when you recover from the XA transaction and then user does drop table, because of other bugs, we have a workaround in InnoDB that if there are open references or open logs to a table, then InnoDB will put the table to an internal background drop table queue. So if you got an XA prepared transaction that modified some table, then even though if you don't do XA commit or XA rollback, somebody will be able to drop the table, which is of course wrong. And this will be challenging to fix because we would have to fix the MDL bugs. There are also some other MDL bugs related to XA transactions.
Okay. I would like to ask you about my absolute favorite task, which is something that actually you made me know about because some time ago I wrote a post on my website about the risks of running an alter table in production. And you mentioned this task, which is about making alter table online in a way that is engine independent, right? So can you talk us about it?
Yeah, originally it started as a different bug, an InnoDB bug. I was thinking that why doesn't InnoDB support type conversions with the native alter table algorithm? For example, if you change a column from int to big int, currently it uses the SQL layer code for changing the type. And then I was looking at the code. Okay, actually it's a very nicely implemented code there. And I was thinking that it doesn't really make sense to try to duplicate that in InnoDB because you would have to convert each row from the InnoDB format to the SQL layer format and back. So I thought that actually this can be better done with by simply supporting algorithm copy, which is the old algorithm which creates a new copy of the table according to the altered table definition and then copies each row one by one to the new table and doing the conversions. I think that one should simply support online operation, I mean concurrent DML. Of course, it's a bit less efficient until InnoDB implements this MDEV 515, which is inserting data into an empty table. Once we have that, then we can do it efficiently in InnoDB, doing this merge sorting and building each index page by page.
Okay.
But unfortunately, it didn't make it to the 10.5 release. It was scheduled for it, but it wasn't finished in time.
Okay. Another interesting thing, in my opinion, is I see not one single task, but a set of tasks that seem to aim to move foreign keys out of InnoDB, correct?
Yes, that was one of my pet hates of InnoDB, that foreign keys don't really belong there. They belong to the SQL layer. If you are supposed to have multiple storage engines, then it should be so that all storage engines support all features that are meaningful to support. Of course, some storage engines don't support all index types or things like that, but foreign keys are not really something that should be at the storage engine level. So this is something that is on the 10.6 roadmap. There was already some change, like there was an InnoDB internal SQL parser, not real parser, but some kind of a hack that used some handwritten scanning, not even a regular expression, to try to find foreign key creation. And it even didn't support all syntax. Like if you create a table and then in the table definition you say column name type references another table and so on, that one will not be recognized by the InnoDB internal parser. But now in 10.5 we have the SQL level parser working correctly, and that case should be supported finally.
Okay, great.
But in 10.6 we should, if I understood it correctly, plan is that in 10.6 we attempt to move the foreign key metadata storage out of InnoDB. And it's probably not going to happen that we move the foreign key handling out of InnoDB in 10.6. We do these yearly releases, so if we are very lucky, then it will happen in 10.6, but if not, then it will be in 2 years in 10.7.
Okay, I see it. Once this will be done, will it also be possible to have a foreign key in InnoDB pointing to a table in another storage engine?
I don't see any reason why not. Also, you could have a foreign key on partition tables, which is currently not supported.
Great.
And also foreign keys would finally work with triggers. You know, if you have a foreign key on delete cascade or on update cascade or set null, then this cascading or set null operation will be done internally in InnoDB, and it will not fire any triggers. So that could also be finally fixed. Okay,
great. So we have a question from my previous colleague, Pedro. Hi, Pedro. And he asks, what are the plans for InnoDB in 10.6? Well, I think that partly you already answered, but probably you also have other things you would like to mention.
Let's see, I'm not currently working on 10.6 features. I'm still working on one thing that I hope to reach 10.5. This is this MDEV 15053, reducing the buffer pool mutex contention. In MariaDB, in MySQL 8.0, there was a Percona contributed patch that split the buffer pool mutex into some LRU mutex and some other mutexes, and then also used some more atomic operations. But when I started to look at the changes, I was thinking that maybe there are some easier ways to make things work better. For example, we have in the buffer pool page descriptor, we have some fields that are more or less transient data, like this flush type. It's only used when you are writing a page out from the buffer pool. So I'm going to move that as part of an other short-time object and trying to reduce the changes to these shared data structures. So that's one thing that I'm still working on, and I hope that it will be part of the 10.5 release, but I can't guarantee that. If not, then it will be in 10.6. Other things in 10.6, I already mentioned this MD515 inserting into an empty table or partition. That would be very nice to have. And let's see what else. We just did this 10.6 planning a couple of weeks ago, but I don't have it in my head right now.
Okay.
So let's see. I actually was hoping that we don't do so many changes. Okay, one thing that I was hoping to spend time on is the handling of corrupted pages. Currently, InnoDB loves to crash when it encounters a corrupted page or any sort of corruption. That would be a huge task to clean up the code, basically go through all of the code and all of the code base and check that if we get some error, then we propagate it to the caller and not assume that it will always succeed. And maybe we can also then remove this this code that flags an index corrupted, because in all code paths we would be handling the corruption gracefully anyway.
Okay.
Another thing that popped into my mind now is that in 10.6 we should remove some things. I have been thinking of removing write support for, no, not write support, but removing buffer pool support for row format compressed. This would mean that if you have row format compressed tables, this is a format that I developed in 2005, and it was really written with hard disk in the mind, because back then SSDs didn't exist. So I think that row format compressed is well past its best before date. But because Monty thinks that we must not remove anything that users may be using or when they are upgrading, then I think we must retain support for row format compressed tables. But I would do it in such a way that I remove the special handling for the format, and which would allow all other cases to be faster. And then I would so that if you write it more frequently and you will get less compression, or I will outright refuse writing to these tables and remove the code to support writing.
Okay. Okay, so the time is almost over, but I would like to ask a couple of more questions. So if it's possible for the answer to be brief, I managed to ask them both. One is kind of evil because it's about past decisions. Is there some past design decision that you regret about, something that you think about today and you say, well, this was a bad decision?
Well, decisions that I have made, I can think of two of them. Or okay, I didn't make this decision to implement a row format compressed. It was Heikki's high-level idea and my design. And I also can't say that or maybe I should not say that it was a bad decision to implement the InnoDB change buffer or the adaptive hash index, because those are very non-deterministic systems and it's very hard to find bugs. I know that users hit bugs with those subsystems, but it's very hard to reproduce them. And even if you reproduce once, it may be difficult to reproduce reliably and to debug it.
Okay.
But another thing that I did let's see, yes, in MySQL 5.7, I suggested that why don't we disable the redo locking when we are executing alter table. We are writing so much redo lock, and it's kind of wasted because we will eventually also be writing the pages of the rebuild table itself. And that turned out to be a bad decision because it's making backups harder and many other things harder. So in MariaDB 10.2, we introduced the parameter InnoDB log optimized DDL, I think it was called. And you can set it off. It's on by default for compatibility with 5.7, but you can set it off, and then all redo log will be written, and backup will not have to recopy the data file.
Okay.
Another thing, yeah, I guess that's mostly those are the biggest mistakes. So in 10.5 we removed the code that disables the redo log writing.
Okay. What would you suggest to a person who would like to understand better InnoDB and maybe contribute to the code and never did it before? Where should they start from?
Well, I mentioned this book by Gray and Reuter. I don't know if it's easily available. I borrowed a copy of it from Heikki back in 2005 or 4. So if that book is available, then that one. And a couple of years ago, I gave a talk about the InnoDB internals. It was called the Deep Dive InnoDB Transactions and Write Paths. So that would give a high level, a bit deeper, but not really to the code level idea how it works.
Okay. And
generally, I would say run some test cases under debugger. We have this regression test case MTR, and that could be a starting point.
Okay, great. The last question is actually a question that I'm asking to all persons I'm interviewing, and it's possible you already answered in part, but I will ask again. Can you suggest 2 books to read for our viewers, given that, currently most people have a lot of time to read? And I ask you to suggest 1 book related to databases and another book related to any topic you like.
Yes, the database book I already mentioned. It's this book by Jim Gray and Andreas Reuter, Transaction Processing Concepts and Techniques, published in 1993. And the non-database book, what is the name of this book? By Julian, I don't remember the first name, but it was released published in 2017. A very good book about logic. If you are into logic, modal logic, or you want to see a proof of Kurt Gödel's incompleteness theorem, that's the book to read. And it starts very low level or easily. You can even read it as a bedtime story to your kids. But then at some point it gets very advanced. So you will struggle to get to the end.
Okay, interesting. Well, it's a challenge. If you get to the end, write a comment below this video. So this was the last question. Thank you a lot, Marko. I enjoyed this interview very much.
Yeah, thank you. It was my pleasure to answer, and also I enjoyed the questions.
Great. Just a quick reminder that a bit later at 4, so in 15 minutes, we will have a brief interview with Andrew Hutchins from MariaDB, and we will talk about his views on software communities and the need for MySQL and MariaDB community to get a common foundation. So if you're interested, see you in a few minutes. And Bye, Marko, and bye everyone for now. Bye-bye.